Welcome to the second installment of our Ask the Meshperts series. This is a number of segments we'll aim to bring you regularly, talking about all things service mesh, microservices, and containers. Today's session is focused on distributed tracing. If you have any topics you would like to discuss in the future, or you'd like to join us for an Ask the Meshperts, feel free to reach out to us at askthemesh.io. We'd be glad to have you or answer any questions or cover any topics you care to hear about. So as I said, today we're going to talk about distributed tracing. Today I have two distributed tracing experts with me. Will you guys give a quick intro?
All right. Hello, I'm Neeraj. I'm the platform leader at Aspen Mesh. I'm part of the engineering team building the Aspen Mesh platform.
Hey, and I'm Joe. I'm a solutions engineer on the team. I talk with a lot of customers around this topic, trying to find out good ways that they can use the service mesh.
Great. Thanks, Neeraj and Joe. So let's think a little bit about why distributed tracing is important to start. We have containers. We have container orchestration, basically being Docker and Kubernetes, and they solve a lot of build and deploy challenges. They make it easy to build and put containerized applications out there, but the promise of containerized applications and the reality of managing them at runtime are two very different things. This is where a service mesh comes in very handy. It helps you manage your applications at runtime in a better way. You get observability, you get control, you get security that you could do beforehand with things like DNS or config management. But with service mesh, you do it all in one place. It's a lot easier, and you get some added capabilities as well. So we want to talk a little bit today about how a service mesh helps with tracing, because there are other ways you can do tracing in microservices as well, but there are some added benefits you get with doing tracing with the service mesh. So before we dive into a service mesh specifically, would one of you kick it off with explaining why tracing in general is so important for microservices?
Sure. So in the microservices world, what I find many operators and developers struggling with is understanding how their microservices are connected, especially within the context of one request. What I mean is when a request comes into a microservice, how many requests is it making to the other microservices? And then how many requests are those microservices making? Mm-hmm. And as your microservice architecture gets complex and this chain is really deep, it is really difficult to understand and grok the entire call graph. Mm-hmm. So this is the problem that distributed tracing solves. It essentially gives you a nice hierarchical view of how your requests are flowing in your microservice architecture. And then at the same time, it gives you the insights and ability to zoom in and point out performance bottlenecks, as in your customer is experiencing latencies. Then you can zoom in and say, this link in the microservice chain is contributing to that latency. So it's both a macro view and a micro view, which is really combined together to give you the simplify for you to understand what microservices are doing and whether they're performing at the optimal level or not.
That's correct. Yeah.
Another thing which I like to think about is the microservices. In the monolith world, module level logging is very analogous to distributed tracing in the microservices world. So in monoliths, you will add logging at various modules, which will tell you what's happening there. In microservices, tracing is what tells you what is happening at every microservices in a much more presentable manner. Joe, you have worked before in monoliths, and do you think it's a good analogy?
Yeah, it's a great analogy. And another thing I'd just like to add there is, as you're moving into the containerized world, you're finding a lot of convergence between the network administrators, the platform leads, the DevOps teams, the application developers themselves. And in a traditional monolith environment, in the traditional networking space, a lot of the microservices are communicating at a layer 7 layer, and there's not a lot of transparency. There's not a lot of understanding of what's going on microservice to microservice. And network administrators, they have their pipe that they open, that they're talking on a TCP level with their port, right? And there's not a lot of insight as to why is there latency, right? And this sort of distributed tracing within the mesh gives insight to not just the application developer, but the whole enterprise itself. It's advantageous to the platform, DevOps, and network team.
Absolutely. That's a great point, because your developers can use it for debugging, whereas your security expert can see if any violations have happened.
Yeah.
Right. Sounds like it gives you a nice high-level view of where the problem is, but also the ability to drill down and get to root cause.
Yeah.
Exactly.
Very cool. Thanks, guys. So, how about how tracing works with a service mesh? If you're using Istio or Aspen Mesh, which is built on top of Istio, how would you do tracing differently than as a standalone?
Great question. So in service meshes like Aspen Mesh or Istio, you get a sidecar. Sidecar is injected as another container in your pod. Because the sidecar intercepts all traffic, it is in a unique position to add all the tracing headers. So that's what the Envoy sidecar is doing in Istio and in Aspen Mesh. It's adding the tracing headers when it's given a new request before sending it to the application, and then when the application is ready to make another request, it will either create child spans that will give you the right nice parent-child relationship of requests, or it will propagate them along. Secondly, the sidecars add the right span tags, such as request fields like HTTP URL, your status codes, your request size, response sizes, and sends it along. So the application does not have to add this information. And third, and the most important thing, is it will automatically report these spans to the tracing backend like Jaeger or Zipkin, which again alleviates the application for doing this work. So essentially, in my opinion, the service meshes are doing all the heavy lifting that you need to do for adding tracing in your microservice architecture.
Yeah, they're correlating it. There's a lot of information that this mesh is collecting. So depending on where your focus is, from application developer all the way to a network administrator, you can query off those traces that's being collected within the mesh, and you're able to sort of drill down and see specifically where things are routed from end to end. It's very useful.
Okay, yeah, that makes a lot of sense. So would you have to change your applications to add tracing if you were using a service mesh?
Good question, especially because this feels like a gotcha question, because everyone in the service mesh world always says you don't need to change your application to take benefit from service mesh. Just for tracing, I would say there is a header propagation that your application should do. What it means is take the tracing headers that you get from your incoming request, and then when you are ready to make an outgoing request to a new microservice, propagate those headers. If you don't propagate these headers, the sidecars end up creating root spans, which means you will only have traces which link two ends of the microservices. You'll never have spans which you'll never have traces which will span across your entire microservice chain.
Okay.
So this is one of the things which many developers or operators are struggling with, to realize that to get the full benefit, you should actually update your application.
But simply, really, it's just adding a few headers.
Well, it is, but there's a difference. So there are different ways you can do it. And I don't want to jump ahead, but I do think as a developer myself, I want to do propagation of headers in the most extensible way. So one thing is you can just cherry pick headers and propagate them. Another way is using the open tracing libraries, which kind of abstract away the headers themselves. So later on, when you want to remove the tracing back and switch to a different tracing system, you can do it.
Okay, interesting.
So it is simple,
Yes.
but it's a little bit more work.
So which of the ways would you recommend?
I would definitely recommend use the open tracing APIs, the open APIs for doing this propagation, rather than just taking out the headers yourself. Because two reasons. One, it enables you to remove your tracing back and then change to a different one whenever you need. And second, as you become more and more accustomed to the tracing systems, what I do, or what normally developers do, is they add more traces within your application. So not only are you tracing your network calls, but you're tracing within your application. And if you have already started instrumenting your code with open tracing libraries, doing that is very easy. So why not take benefit of it?
Yeah, that makes sense. Okay, cool. And I'm going to ask another question that may be less important, but I know we use Jaeger in-house at Aspen Mesh. It's one of the options you get with Istio. Zipkin's another option. I think there is a third one as well. But any insight as to why we use Jaeger? Any recommendation on why somebody might want to use Jaeger over another tool?
So we started using Jaeger because Jaeger was a CNCF project when we started. So it had a nice ecosystem with reliable governance, so that we can say, okay, there are releases, there is some quality to the release. It has a nice community which is sustaining it. That was the first thing. Second thing is Jaeger as a tracing system is a superset of Zipkin. So Jaeger also supports Zipkin format, so you don't lose out. And the third and the most important is there are a lot of new advancements that Jaeger is doing around advanced sampling and some sort of adaptive sampling, which is really nice because you can make better judgment about which spans and samples to collect. So in this ecosystem, we recommend using Jaeger because I think there's a lot of active development going on. Does not mean that Zipkin or the other systems are not good. It just we find that Jaeger is much better.
Well, I just find it from an administrator's point of view, it's very intuitive how you can drill down and you can see all the correlations between each step that happens from microservice to microservice. And you can see the latencies in between. You can see errors. You can see who's communicating to whom. It's very intuitive.
And just to add to that point, Jaeger recently added a new mechanism where you can diff between two traces. Now that's something that we have been starting using, especially since our SRE joined Aspen Mesh.
And does like comparisons.
Exactly. So just an example of how an open source ecosystem which has a lot of people behind it. Even though you might have various options, you want to pick the one which has a lot of active development.
Yep, that's great. So Joe, I'm going to throw it back over to you. Joe is our solutions engineer, spends a lot of time talking with our customers. Any customers you've talked to recently that have called out how they're using distributed tracing? Any real world kind of neat use cases you've seen with some of our users?
So one is and this would be why distributed tracing is useful to them in an environment like this. It was a traditional monolithic, healthcare provider type environment. They had a lot of legacy information. They decided they need to modernize. They decided they wanted to go with the containerized microservice. And so they set up a team. They have Kubernetes. They have different dev teams in different Kubernetes environments. Right? And they've really committed to updating the network. They're committed to worrying about latencies. So the infrastructure can support this microservice environment, but they have a lot of traditional tools that doesn't give them the insight, right? Their networking tools aren't telling them, what's going on, communication to communication. Their security teams are a little wary of this because they don't know who's communicating to who, over why, and what's being delivered and how. Is it secure? Is the information secure? So by adding this service mesh, it gives a sort of a uniformity across all the teams. It allows the networking team to see the amount of time that's taking between the microservices. It allows the dev team and the DevOps team to be able to say, microservice to microservice, how long is it taking? What are the latencies? Where is the issue? And because what was happening is they were coming up with a lot of, hey, I ran it in my little container environment and it was super fast and it was great. And then now it's taking me forever to talk to my database. So then they'd have to track it back and say, database administrator, why is it taking so long? It's fine. It's not. It's great. So this allows them then to correlate and say, all right, within your containerized microservice environment, what are the steps? What are the latencies when you put it into the enterprise networking infrastructure? So it just allows all the groups to sort of have this common, uniform display of how are the microservices communicating with each other.
That's a great point. One word which jumped out when what Joe was saying this is uniformity, which is really great for people who were used to managing monoliths. When you have a monolith, you have one place to go to understand things. Now you have 100 different places to go to. So that's why doing tracing in service mesh is so important. It gives you one place to insert that uniformity so that it doesn't happen that one span for a HTTP request is HTTP underscore request, and the other one is calling it something else.
Yeah.
Like it just makes it very difficult to debug things. So, and the second thing is, like you were saying, you want the same debugging tools or the same capabilities you had in the monolith world. You really don't want to lose them. So I think tracing gives you back that power.
Yeah, absolutely. Great. Well, thanks, guys. I appreciate the time today. As I mentioned earlier, if you'd like to drop us a line to participate or have any questions we can answer, we're at hello@aspenmesh.io, and you should go check out the blog as well, because Neeraj has some pretty good tracing blogs on there.
Yes, he does.
Okay, thanks, everyone. We'll see you for the next one.
Thank you.